Friends, welcome back to this second session on the same interesting topic of enhanced oil recovery. To assimilate the contents of this session, as advised, you need to go through part 1 to understand the terminologies mentioned there in detail. Now we would be looking at the upstream oil and gas processes, and in this is where we would be introducing you to different phases of a well and enhanced oil recovery. So the first phase, as we are aware, is a primary recovery. This is done by a reservoir geothermal pressure. As you are aware, there is an inherent pressure in the reservoir which tends to push the fluid to the surface. Another important phenomenon occurring in the reservoir is called a solution gas drive. Whenever the pressure in the reservoir falls below its bubble point, the gas expands, and with this expansion there is ample of gas produced, and the inherent property of gas ensures that it carries along with it water as well as crude towards the surface. As you may be aware, the solution gas drive accounts for major part of the recovery in a primary phase, and this is around 20 to 25% of oil initially in place. Then the other phenomenon is gravity drain. This is basically due to gravity. Most of the fluids, including water and crude, gravitate towards the reservoir, thereby pressurizing the reservoir. So this also ensures partial recovery in the primary phase. Then a very important phenomenon is aquifer influx, whereby water from the parallel aquifers or the cross aquifers, they tend to pressurize the oil bank, pushing it towards the surface. So these are different methods by which primary recovery is ensured. So with a good proportion of oil recovered by natural means, that is around 20 to 25% of oil initially in place which is required during a primary recovery, there is still surplus of oil in the reservoir which needs to be extracted by some assisted methods, and this is where secondary recovery is introduced by providing some artificial lift. One of the most important methods of doing this is by gas lifting. Now, as the GOR of the gross fluid reduces, its pressure also reduces. Thereby, this gross fluid, which comprises of oil, water, sand and gas, tends to exert a considerable back pressure on the downhole and preventing flow or choking the fluid. So this back pressure can be equivalent to the length of the production column, or sometimes it depends on the depth of the reservoir. To overcome this back pressure, the easiest method is to introduce recovered gas at different elevations along a production tubing. This reintroduction of produced or recovered gas tends to considerably reduce the density of the gross fluid, thereby also reducing the back pressure on the downhole and re-establishing flow through the production tubing. Now, gas lift can be done with different objectives. One of them is continuous introduction of gas, whereby this is done over a full life producing cycle of the well. Then there is intermittent gas lift, which is done to eliminate slugs or gas pockets in the production tubing, and this can be done based on the depth at which the mandrels are placed. It can be done at different pressures ranging from 180 to 1800 psig. Gas being a highly sought after commodity because of its benefits for using as fuel as well as feed for petrochemical plants, for fertilizer as well as power requirements, many companies refrain from using gas for gas lifting or reinjection. In such cases, they prefer to do the other secondary recovery methods, which is using beam pumps, electrostatic pumps and progressive cavity pumps. Or there are other methods such as produced water flooding, whereby water is flooded from the injector well towards an oil bank. This flooded water pushes the stationary oil bank from the injector well towards the producer well, whereby it can be pumped out. So basically, this is what we regard as improved oil recovery. These are the secondary recovery methods, which we also call as improved oil recovery, and this accounts for around 40 to 50% recovery of the oil initially in place.